Hey everybody, this is Larry. I'm going to try to do this. It's May 24th here in New York City. I am trying to do a problem that I haven't done yet. Yeah. So hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. I'm trying to do. I used to do them in RNG, but now I'm trying to do them as reverse order. See if maybe it's a little bit different, maybe a little bit more difficult. Yeah. Anyway, today's problem is 3135. Equalize strings by adding or removing characters at ends. Okay, given an initial and target, the task is to modify initial by performing a series of operations to make it equal to target. In one operation, you can add or remove one character at the beginning or the end of initial. Return the minimum number of operations required to transform initial to target. Is this just LCS or not? Substring, not subsequence, right? Maybe not. No, I mean this is still yeah. Because if this one, then the longest is XX, then now you have to be it's three on each side. Right here, the LCS is DE, right? I think. So then now you have CDE. So the LCS is 3. So then now you have to get rid of 2, right? And then add that one, so that's 3. Is that still right? Yeah. I think it is just LCS. But then 1,000 won't make sense. Maybe I'm not thinking about this quite right. I mean, because LCS is just, is it? Am I thinking about it wrong? It's O of N, isn't it? Or am I thinking? Or is that the N square one? Yeah, it should be O of N plus M. So that's why I'm a little bit Well, I guess it's O of N if you use suffix tree, which is why this is always a little bit tricky. But we could do the N square one for sure, right? Yeah. Yeah, I mean, I'm trying to think what's the best way to implement it. But I think it is just literally, yeah, best is equal to 0 for I in range of N, for J in range of M, something like this, right? We'll see if this is actually right though. I think it's LCS, but I don't really have a tough proof. It is just that because you're keeping this, then everything else must go, right? So yeah. So then now we go. How is this going? Yeah, it's been a while. So if I is equal to target of J, then now this means that dp of ij is equal to dp of I minus 1, j minus 1 plus 1, right? Else dp of ij is equal to 0. Right? Something like that? Is that it? Right? I mean, that seems pretty straightforward, right? Or am I just like being dumb? I don't know. I feel like I haven't done this in a long enough time to be dumb for me. But yeah, and then we just kind of put this way. Maybe we could do some optimizations, but I feel like I'm okay. Best times 2 because best on both sides, right? Something like this, but what is best here? Why is that? What do I think is best is 2? Why? Huh. Am I missing something? I mean, it's possible that I'm just being a little bit dumb. So that is 3. Oh, I'm just dumb. I am dumb. Because, yeah, if I minus 1, okay, fine. That is just dumb. Give it submit. Hopefully, I mean, if I'm wrong, that's fine too. Then okay. Yeah. I was trying to think. Most of my thought process is trying to think why LCS won't work, or longest common substring. And the reason why LCS would work is because that's the part that you're keeping, right? Because you can only remove at the beginning and the end. That the longest substring is the part that you're keeping. And then it's just about figuring the cost, which is going to be basically we keep only the core part unchanged, and then we remove and add all the other ones. That's how this can recur. But yeah, so this is going to be longest common substring, and we did it with dynamic programming, which is going to be O of n squared. But I'm pretty sure. I mean, let me Google it actually, since now that we're done. Suffix tree maybe. I think with suffix tree, you can do it in linear time. I don't know. I think I clicked on a silly link by accident. Geek for Geeks. But yeah, I think you could do this with suffix tree in O of n times m, and this is n times m. Sorry, to be more precise. And you could do this with O of n plus m times, because I think you could convert it into one. You could do like the trick with target plus $sign plus initial plus pound, or the other way around. I always forget which way. And then as a result of that, we do a suffix tree. Then now you can do a search on a tree where I guess a certain substring happens shows up twice, or something like this, right? Don't really. I mean, that's the you have to play around that idea, but I think that's basically it. You can maybe construct a suffix tree with this as well, but I don't remember. It's been a while. But yeah, all right, that's all I have for this one. Let's take a look to see if people talk about suffix tree. I mean, you could do with brute force DP and Warburg-Kopf, right? What does that mean? Or like, why? But yeah, I actually did forget that I was just trying to figure out the LCS part, but you can actually optimize so this is the time, right? The time you can't do much better, but you can actually optimize the space to be like O of n space or something like this, right? Because you could do a space optimization. Very straightforward to do. I'm not going to go over it. I'm going to go back to the Rangers game. So yeah, that's all I have for today. That's all I have for this one. Let me know what you think. Thanks for watching. Yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.